Okay, Algebra 2, Lesson 8.4, Continuous Compound Interest. Continuous compound interest. Here's the thing. The P is your principal, as we call it, but that's really your starting amount. It's your starting amount. Now, we're going to see on the second page that you don't always have money, but for right here on the front page, it is all dealing with money. But A is the amount that you have after T years. And then you can think, well, what about E? E is that very famous number in higher mathematics. It's much like pi. It's a constant. And it's about 2.71828. And we'll use that in the calculator to help us. Your R is your interest rate. And it's your rate as a decimal. Convert your percent by dividing by 100. Please do that every time. And then T is your number of years. So as you're looking at this formula right here, as you just glance at this, I hope you're going to notice it spells out PERT. Now, there is a shampoo called PERT shampoo, so you can remember that. By the way, we will give you this formula. We're going to have it, up on the board when you take your test. Also, when you read continuously, it has that phonetic E sound at the end. And that's going to remind you to use the formula with E in it. So A is equal to P times E to the RT. So here's where we're going to go. We're going to use this formula for really every problem that we've got today with some adjustments. But let's read. The initial amount, that's your starting amount. P equals $1,300. Okay, that's what you begin with. As we continue reading, we can see there's a rate of 4.5% per year. Now again, this probably doesn't surprise you because I've been talking about this for a while now. The number one mistake that kids can make is they forget to change this into a decimal. And of course, we'll get 0.045. Please watch out with that. Take a moment just to type that out every time. Be safe with it. Even last period, as I was helping kids, they got kind of upset. They were saying, hey, I think I know what's going on, but I'm getting it wrong. And, sure enough, they didn't divide their interest percent by 100. Then we're going to have 4 years. We're going to have T is equal to 4. Guys, here's the real cool part. It's very formula driven. And I'll tell you what, you just have to put this in the way you see it. 1,300 times E to the 0.045 times 4. So here's what you got. The E, if you look for it, it's right by the 4. We're going to say second ln here. And we'll just type in 0.045 times 4. And we will get this answer. But notice that they want you, in this case, to answer to the nearest penny. So you'll get 1,556 points. And to 2 decimal places, you can see that's 0.38. You look to the right, it's not going to round up. And that's how much money you would have if you were earning continuously compounded interest. Okay. Any questions on that? All right. For example 2, this is way different in this regard. Please notice how much should be invested now. What should you start with? You don't know what you're starting with. And you'll get a question like that. You got to think about this a little bit differently. Your R with 5%, we can just type in 5 divided by 100, and you'll get 0.05. And we want to have $2,000 after 3 years. So you want to end with $3,000. So here's what we've got. You're going to put 2,000 over here, and you're going to have 0.05 times 3. Okay, here's the thing. You want to solve for P. You're trying to find P. What does it mean to solve for a variable? Get the variable alone. And right now, P is not by itself on the right-hand side. In fact, it's being multiplied. Whenever two items are right next to each other, it's implied multiplication. So tell you what I'm going to do. I'm going to divide by this e to the 0.05 times 3. And you can see this is going to cancel out. Now, this is where, guys, when you're working this out on your calculator, you could make the fraction show up. Alpha y equals, and we'll type in 2,000. Divide by, here's your second e, here's your 0.05 times 3. And you can see you get $1,721. But look, this time the 41, if you look at the 1 to the right of it is a 5. You've got to round up to 0.42. So 1721.42, that's how much money you'd have to start with, how much you'd have to invest now if you had this interest program earning 5% a year continuously, so that after 3 years you would then have $2,000. Okay? So let's go to the second page. And I think sometimes kids look at this and they think, oh, great, another formula. Guys, it's really the same formula. Guys, it's PERT once again. It's just that your A sub 0 is equal to P. It's your starting amount. It's also known as your initial amount. The word initial means starting. Okay? Your R is still a decimal. But here's the big change. You're going to be reading about growth. You're going to be reading about decay. You're using this PERT formula for sure. You're using that for every single one of these. But if you're dealing with growth, your R will be positive. If you're dealing with decay, you're going to have your R being negative. So that's the only huge difference. T is going to be time units. T does not have to be years here. So let's read this together. For example 3a, the number of bacteria. You can see we're not talking about money. We're talking about a population. You could have a population of animals, bacteria, people. All of that could be represented by what we're seeing here. But it's continuous exponential growth. So you could just go right back to the PERT formula, in all honesty. And we're told that you've got 18% per hour, but because this is growth, your R is positive. So our population is going up. Because of growth, that means keep it positive. From here, it says you've got an initial population of 65. You could put in P equals 65. And then you're going to have 5 hours. So T is equal to 5. So we'll have 65. Here's E. Your R is 0.18. And then your T is going to be 5. So what you do is you go 65, then you go second E, you'll go 0.18 times a 5, And you'll get, going to the nearest tenth right now, that's 1 decimal place, 159.9. We're going to have to round that up. And you're done. So, once again, it's very much the same type of problem. You're going to have to always divide by 100 for your R. But now adding to a little bit of complexity, your R could be positive, your R could be negative. If you're talking about growth, your R has to be positive. Let's do our last one. For 3b, the mass of a radioactive substance follows decay. So it's still the PERT formula. But this time R is negative. You can read immediately. If I've got decay, I've got to deal with my R. They're saying that you have an initial mass of 8,859. That's what you start with. Initial means start. And you've got 11%. So you could say I'm going to take 11 and divide that by 100. And we're going to get 0.11, but guys, it's decay, so we got to make that a negative 0.11. We'd like to know what's happening after 2 days, so I'm going to say t equals 2. So right now, you just have to type this in. Plug in your R of negative 0.11, plug in your t of a 2, and guys, here you go, 8859. We're going to say second E, negative 0.11 times a 2, and you get 7109.5. So that's all we're doing. It's the same exact formula every single time. Just have to read the question.